Good evening, Mr. Firdaus. We are from Computational Thinking Group 3, and we will present to you about our case study about drone delivery system. Let me introduce myself. My name is Clementio Perez Legata Rombongan.
My name is Rashadi Farul Arashi.
My name is Muhammad Rafedisa.
And my name is Muhammad Gazin Hindami.
Okay, we'll proceed to the outline. First, we have introduction, then we proceed to problem analysis, and then we have key variables and objectives. After that, we have pattern recognition, and with that, after that, perhaps we have abstraction, and then we have algorithm, and then we have the example and demonstration, and then lastly, we have evaluation. Okay, so these are the contributors. Okay, let's dive into problem analysis. So the problem is with the rise of e-commerce, companies are exploring autonomous drone delivery system to reduce their cost. However, operating drones in urban or rural environments have a lot of challenges on obstacles and adapting to weather condition and managing battery life. We need to design a computational solution to optimize the drone delivery routes. First, we have to consider real-time data, obstacle avoidance, delivery priorities, and energy efficiency. Now, from the problem, we have key variables. First, we have package urgency, and then we have air traffic, and we have distance from A to B, and then we have energy cost, and then we have to take account of the package mass. And we also have the objectives, that is finding the most energy efficient route, choosing which package to deliver first, and then creating a system to avoid obstacles. And these challenges are obstacle avoidance, air traffic, weather condition, and conflicting requirements.
So we're gonna have to go to pattern recognition. First is energy efficiency route, which first energy cost is dependent on package mass and distance. Secondly, drone will always fly in an altitude of 120 meters, which is the federal limit for a drone. And third, mass of the drone will always be 65 kilograms, which is based on the DJI flycart to the package delivery zone. Secondly, with the package priority can be separated into different tiers, which let's say they are priority, regular, and a budget, and the tier number will give weight on the package urgency. And we have obstacle avoidance. There is an obstacle that obstructs the drone from going to a straight line, which moving to the left or right of an obstacle is more energy efficient than moving upward. Drone will find the most optimal detour until there is no more obstruction.
So we're going to be moving on to abstraction next. So for the energy efficient route, each package contains these informations: address coordinate, package mass, and priority level. And for the warehouse address is set at 00 for simplicity's sake. And the distance is x2 plus y2 to the power of 0.5. Energy cost of package delivery, energy cost is assigned to each package using the previous formula. And for the urgency, energy cost is on the priority level. And lastly is time complexity, ON. Next. So for the package priority and pathfinding, its urgency of each package is put into an array. Utilize heap sort to order the array from lowest to highest urgency score. The lower the score, the more urgent the package. Pick the package corresponding to the urgency on the list. Drone is not water resistant, thus won't fly when raining. So for the height is Z, ground level is Z, meaning 0. Fly up until Z is 120 meters. Go in the direction of address. When on address point, lower Z until 0 and release the package. And lastly, for the obstacle avoidance, combine with the pathfinding to calculate the optimal route.
Okay, so let's move on to the algorithms. These will help in helping the drone sort the packages and also getting up, finding the optimal path, and going back down. So here we have a star pathfinding for the pathfinding, of course, heap sort to sort the packages, which will be then linearly selected in the order that was sorted, which is from linear selection. Now let's go to A star, which is an intelligent pathfinding algorithm that helps drones find the shortest and most efficient route from A to B whilst also considering obstacles. So why we use this one is because it's one of the most efficient route findings for the drone while also avoiding obstacles. So it's a 2-in-1. And basically how it works is that it has Fn, which is a combination of Gn and Hn, where Gn is the actual travel cost and HN is the estimated cost to reach the destination from a certain point. Next, here is the flow diagram on how it works, and here is the code we implemented into the program.
So next is heap sort. Heap sort is a smart comparison-based sorting algorithm that organizes data like a priority pyramid to sort elements super efficiently. What's special for drones? First, it's speed champion, where it always runs in O n log n time, and also a memory saver sorts data in place, and priority ready, perfect for real-time task sorting. And the key components is a binary heap, a tree where every parent outranks its children. Well, and two magic phases were heapify, convert unordered list into a valid heap, and extract and sort, repeatedly plug the root, and rebuild the heap. So this is the flowchart diagram, and this is the code. So we use the object-oriented programming to fulfill the parameter of this case study.
So let's move on to linear selection, which is just an algorithm to find the largest or smallest element in an unsorted array without fully sorting the data. So it's just going to go from first element to second to third to fourth until it's finally finished. So the worst case for this is n, because it's just picking one and then moving to the next, which is just n. And that's all to it. Here is the code for linear selection in our program. And here is the flowchart of the entire program, or at least the main part of the program. We can go next. And here is the code to our program. While this one shown in the presentation is not all of it, it is the main part. For the everything else, it will be inside of the link on this presentation, and we will also be including it in the submission. Okay, so big O analysis. For the heap sort, it's just n log n. For the pathfinding, it's v log v, where v is a different variable based on search area divided by position precision. And linear selection, on, as previously stated. So its overall time complexity is n log n plus v log v, while the space complexity of all of them is just 1.
Okay, now we proceed to the example. So we have a package and we set the address to 170 and 45, and the second package to 170 and 50. And we set the mass for 1 is 20 and for 2 is 12. And then the priority is 1 is 1 and 2 is 2. Okay, now from the calculations, we have the urgency is 1 for 1 is 4.92 and 2 is 11.94. Okay, now we proceed to the sorting, and with the sorting we use heap sort to get its coordinates. And then we proceed to the pathfinding. There we have z is equal to 120 based on the Federal rule, and then we iterate the location, destination, location, destination, and new location until n, or until the target is found. Okay, now this is the case example. First, we set our number as n, and then we proceed. The program will then determine the urgency, and then after we determine the urgency, it will land with a fine-tuned final approach. And then it will put the package and then return home, and then we'll continue until the next item. And then these are the evaluation, and these are the references of our case study. Thank you for listening to our presentation. If you have any questions, please just ask or WhatsApp us.